Hello friends, welcome to my channel. CPU's 32 version, because without improved USB device compatibility you won't be able to update your BIOS to later versions. As now my BIOS version is F23, first I have to upgrade my BIOS to F32 and then I will be able to update my BIOS to latest F52A. First, I have to download F32. I will provide this site link in my video description. You can access this site from there. So after downloading, open continuing folder, unzip it. Now after unzipping, there are two processes. You can either run this flash exe file within your Windows desktop, and your system will automatically detect the BIOS update and your PC will restart and BIOS update will start automatically. Right now I am recording this in another PC, that's why I am going to do the BIOS update with the help of a pen drive. So I am going to copy all these files in a flash drive. And then I will open BIOS settings in my desktop. So friends, after copying the BIOS files in the flash drive, right now I am inside the BIOS of my Gigabyte A320M S2S motherboard. Here you can see my current BIOS version is F23 and now I am going to update it to F32. So first I will connect my flash drive to the CPU and then inside the BIOS I'll go to Q flash. And there are two options, save BIOS and update BIOS. So I will select update BIOS. Here you can see it has already detected my flash drive, and at the right side I am seeing that A320M S2S F32 BIOS. So I will select it and I will click this right arrow to proceed further. I have to click here to start. So BIOS update has started. Please keep in mind a stable power connection is necessary during BIOS update. Second, the BIOS has been updated to flash. Select update will start automatically. Right now I am recording this in another PC. Open BIOS flash drive. Right now you can see exact BIOS update. I will click and I will click this right arrow. And then copy the contents. Next, get my set performance without overclock. With overclock setting, you will get slightly 5% 8% faster performance. But as this is an entry-level board, this device is not that powerful, so temperature might be an issue for the VRAM. That's why I don't recommend to overclocking with this
Comment ça va? Là, c'est mieux. Oh, comment ça va? On est un peu en retard, mais ça va. Oh, je suis en train de regarder pour mettre à jour mon BIOS pour augmenter mon processeur parce que ça rame un peu avec, avec un Ryzen 3, donc on va augmenter. Nouveau des problèmes de live là, putain. Putain, j'ai une coupe à la années 80. Alors, c'est plus support. Il m'a juste le AMD Ryzen 5950X. Ok. Écoute, lui. 259 €. Ah ouais. Ouais, bah. Ouais, non. On va pas prendre ça. Le son est bon ou pas? On m'a pas chier mon téléphone. Est-ce que le son est bon? Ouais. Ok, est-ce que le son est bon? Ok, est-ce que le son est bon? Ok, le son a l'air plutôt bon. Ok, le son a l'air. Après, c'est le matin, ma voix diffère de n'importe quand, donc. 2 secondes. Super. Non, on va prendre, je pense, le Ryzen 700x. Ouais. Ah, 249 €, mais vous êtes fous pour un processeur ou quoi? Putain, ils sont fous. Ils veulent me défoncer. Mhm. Bon. Je vais faire la commande, c'est tout. Juste. J'attends juste, je regarde juste. Ah putain. Oh, ça se fout de ma gueule. Voilà. Mhm, mhm. Allez, on va bosser. Mhm. Mhm, mhm. Ok, c'est bon. Bon. Ok. Bon. Décommandé, donc voilà. Allez, c'est parti. On était sur 16,50. On a été à la vidéo, la deuxième, ou la première, je sais plus. Non merci. Pas tout de suite. Nous on était au fait, on était au premier truc. 16,50. Alors. 16,50.dev. Et voilà. On était au fait. Qu'on était où? On était là? Non, c'était pas ça. Ah mais c'est... Oh là là. C'est une fille, j'ai regardé des vidéos en avance. Non. Ah bah non. Où est la vidéo que j'ai vue hier? J'ai l'impression qu'il y a que des vidéos. On est d'accord qu'il y avait une meuf, non, qui faisait... D'accord. Bon. Quelle est la vidéo d'hier? Je vais voir. Ah, attendez, section, je pense. Voilà, ouais. Tac. Je sais plus on était où, mais on devait être pas très loin de... Ah, voilà. Pas très loin de la fin.
So I can see that, yeah, exactly. I have print row 4. So I don't want to hard code the number, right? Like I want to make it dynamic. So I'm going to change it to height. And this way, whatever user input puts in, I will be able to dynamically change that. So let's make Mario again. And let's run it. What is the head of the pyramid? Let's say 6. And I'm seeing 6 hashes.
Oui, du coup on était sur la Mario. Du coup on était presque...
So as we saw
Mario.c. Je sais plus on était où. On était au fait que... Bah, ah oui, si, je me souviens. On était au fait que Mario.c commençait. On n'avait pas encore fait et voilà. Request time pour 75 minutes. FFC. Ah non. 16,50. Hop, c'est parti. 2 secondes. Qu'est-ce que je voulais? ouais, 4 novembre, j'avais pas vu. Mais what the fuck? Pourquoi il... Ah, il a pas de thermite, les gars, et elle livre pas avant 4 novembre. Hmm. Bon, c'est pas très grave. Je regarderai. Ah ouais. Le 24 octobre, c'est une dingue. Oh là là. Bon, il faut que je me concentre. Hein. Faut que je me concentre un petit peu, je crois. Je ferai ça cet après-midi. Ok.
Here, the pyramid can be different sizes, right? So in this case, the pyramid is of height 6, but it can be of height 5, 4, 3, 2. We will leave this up to the user. Then the second steps and print a pyramid.
Là, du coup, on avait commencé un nouveau truc. C'était dans Mario.c. Du coup, on avait hashtag include H. Ah oui, il faut les guillemets, sinon ça ne marche pas. Include aussi. Include CS50.age. Ok. À l'intérieur, bon, c'est comme habituellement, main slash void. Tu mets ça, mais tu mets la première fonction ici. Donc ici, il va dire le prompt user from puts. Ok. Bon, après, ensuite.
Print a pyramid of that height. Oh, so many typos. All right. Well, this is simple, right? 2 steps.
Ça, c'est la taille. Hein.
Why do we make such a big deal out of it, right? It's just 2 steps. But it takes time, right? Like it takes, again, building blocks and components to make this work. So the first one we've tackled before, so we can deal with this right away. So let's call it int height, and I'm going to print, I'm going to prompt my user for an integer, and I was like, and I'm going to say, what is the height of the pyramid? Question mark, leave space, semicolon. Okay. Next, we want to print a pyramid of that height, right? And that's where things get a little bit tricky. How can we go? Okay. Next, we want to print a pyramid of that height, right? And that's where things get a little bit tricky. How can we go from 0 to 100? Like, right, how can we printing? But let's go, again, building blocks. Let's start with the idea of like printing a row, right? So I want to print one row at a time, and this is what I'm going to start with. And for that, I'm going to create a separate helper function. So I'm going to call it print row, and it has return type void and the input void because we're not taking, oh, sorry. We're going to return type void, but we're actually going to take in something, right? We want to make sure that we're printing different length, right? Our rows have to be different. So we're going to put in the variable called end bricks, right? Tell me how many bricks I need to print on each row. And here, what I'm going to do is printf, hashtag, right? Okay. And then in here, what I'm going to do, I'm just going to say print row for semicolon. So we've created a function, print row, that will take in the variable int bricks, we'll print some hashes, and the way I know how many bricks to print is by passing in this value here. So let me make Mario, and I am running into the first issue. So call to undeclared function to print row. How do I tackle this one? Oh, beyond forgetting this guy, yes. But how do I tackle the error? Exactly. I also need to make sure I prototype it ahead of main. So what I'm going to do, and as Professor Millen says, this is the only acceptable time that you can copy paste in CS50, but I'm going to copy this guy and put it on the very top before my main even starts. And the reason I'm going to do that is because I'm reading my program top to bottom. So I'm going inside of main and I'm going through line 9, I'm getting input from the user and I'm getting to line 12. And without this prototype, main does not know what print row is. Like, right, it can't like look ahead and jump below it. It just sees what it is, what it has right now and what it's seen before. So in order to avoid these errors, we have to prototype this function before. Let's try to make it again. So make Mario. Okay,
Mario. Make Mario. Moi j'ai toujours des erreurs. Qu'est-ce que j'ai fait? Qu'est-ce que j'ai fait de mal? Qu'est-ce que j'ai fait? Make Mario. Ah putain, encore. Il y a encore un truc. Ça c'est bon. Ouais, je me disais bien. Make Mario. C'est bon, ça marche. C'est bon. Slash Mario. 8.
Piles. That's a good sign. And now we're going to run it. What is the head of the pyramid? For example, 5. Okay. I'm getting just one hash sign. This is not at all what I wanted to do, right? Okay, I'm seeing some suggestions in the chat. This was solving our scope issue. Okay, let's take it step by step, okay? So right now I'm just sort of like printing our hash once. What I really want to do is have some kind of for loop, right? Like do it multiple times. And for that, I'm going to do...
Voilà, c'était sûr qu'il fallait une boucle. For. Et on va faire int est égal 0. Alors les boucles, je ne connais pas du tout en C.
This int I equals 0, right? This is how we initialize it. We're gonna print out like some number of bricks, right? And
Et
bricks is
on va créer
exactly
une variable.
the variable that gives us that information. So I'm going to set
White bricks.
I less than bricks. And I'm going increment I at every step.
Je suis sûr à définir la variable plus tard.
Going to move.
Bricks. Plus. Alors je sais pas du tout pourquoi on met, mais ok.
Move printf hashtag inside of the for loop. Indent it. Let's make Mario again. Okay. Height of the pyramid, let's say 4.
Ok. Non. Non, slash Mario. Euh, 4, parce que bah, du coup on a mis 4 là. Normal.
Okay. It's printing out 4 hashes, so that's a good sign. But what if I want to make 5 hashes? Still printing out 4. Where is my mistake here?
Il faut mettre dans print.
Why does it keep printing out 4 hashes even if I put 5 as a user?
Regarde, si je mets 5 par exemple, on peut aussi tester. Make.
Any suggestions?
Oh,
So
2,
I
3,
can
4,
see
5,
that-
bizarrement.
Yeah, exactly. I have print row 4. So I don't want to hard code the number, right? Like I want to make it dynamic. So I'm going to change it to height. In this way, whatever user input puts in, I will be able
on demande.
to dynamically change that. So let's make Mario again and let's run it. What is the head of the pyramid? Let's say 6. And I'm seeing 6 hashes. Okay, that's a good sign. But again, I'm missing the new line, right? Like that's just so annoying. So I'm going to go in here and create a new line. And so I'm going to make Mario. Mario, what type of pyramid? 5. Ugh,
Ah ouais,
this
effectivement,
is
ça
not what I
marche.
wanted again, right? Like it's printing out in the column. I still want it in the row.
Qu'est-ce qu'elle a fait? Ah oui. Un backslash et elle met un N.
I'm going to make Mario. I want it again, right? Like it's printing out in the column. I still
Ouais,
want
je
it in
crois
the row.
savoir.
What can I do different? How can I change this?
Faut ajouter à chaque ligne.
Create a new line at the end of the loop. Exactly. So instead of creating sort of like a new line every time I go through my for loop, what I'm going to do is just print f a new line right here. Let's make Mario. Oops. Semicolon.
Ça marchera pas, elle l'a pas mis.
Mario.
Elle l'a pas mis dans la
Run
boucle.
Mario. What is the header pyramid? 5. Okay.
Ça marche? Sérieux?
We have a row. We have a row, people. This is awesome. So this is one of the
What? Oh, it's possible. Make Mario. What?
first steps in our mission of creating a Mario pyramid, okay? So what we did so far is created a separate function called print row. We created a for loop in which we print out hashes. We also print out a new line every time we finish that for loop. And then we've already pre-set up some of those building blocks inside of the main function. I'm going to pause right here for a second and ask, what questions do we have about these steps so far? What questions do we have about this code, the way we used our various tools?
Various tools. Elle fait des fins de son. Trop marrant.
Any questions about this so far? All right, seeing none. So let's keep moving along. So let me just run this one more time to illustrate what we're tackling here. So right now I'm just printing out one row at a time, right? But I want to have this it's like a stepping stone construction, right? Like I want to have multiple rows. So how can I do that? Well, we're going to make use of the for loops again. So instead of just calling print row function one time, we can call it multiple times, again, using our for loops. So in here, I'm going to create for int I equals 0, I is less than height, I plus plus, and then inside of the for loop, I'm going to move this line of code
Hey, I.
right here. Okay, let's make Mario.
Qu'est-ce qu'elle a fait après?
Right here. Okay, let's make Mario. What is that pyramid? 4. Okay, so this is resembling what we need to do a little better. So just
What? J'ai une erreur, moi. Attends, voilà. Si j'ai pas mis. Make Mario. What? Ah, 2 heures. Une. Int est égal 0. Int et I est égal 0. C'est normal. Si la boucle ne peut pas marcher. C'est bon. Qu'est-ce que j'ai fait encore? Il a fait hi. Alors j'ai bien écrit hi. Tu peux voir, je me trompe. Ça peut arriver, mais là, non. Ok. Bon. On réessaye. Make Mario. Ok. Bon. Make Mario. Alors j'ai une erreur, mais je sais pas où. 12, 37. 12. Toujours dans la boucle. for int i est égal 0, 2 points. J'ai pas de point virgule, je me suis trompé. Ok. Point slash mile 6. Ah, nickel.
Let's make it a little better. So just having 4x4. So name int is if we can manipulate word by using inputs.
Faire à chaque
with
fois un
int
plus 1, je pense. Hein.
Yeah, so there are different functions or like have different variables that they use. So even though we put in height right here, we can we're referencing bricks inside of the print row because that is the variable that is the variable that is defined within the scope of print row, and therefore if my height and bricks just like match of where I want them to match, right, on the print row input, I can just be using bricks inside of my function because this is what I defined earlier. Okay, so here's the issue, and let me propose that we can solve it. But we have a 4x4 grid, and it just seems to be like doing the same thing over and over again, right? Like it prints 4 hashes 4 times. It's very like static, right? It's sort of like almost constant, except for the fact that we can get a different input from the user. How can we make it more dynamic, right? What is the variable inside our main function that will give us this like dynamic option? What is the variable inside our main function that keeps changing with every iteration? Remy said replace height with I. Exactly. So you can notice that inside of our main function we have 2 variables, height and I. And in fact, height, after the user inputted that number, that is it, right? Like that is where it stays, it does not change. But I, on the other hand, changes with every iteration of the for loop, right? Like it increments by 1 every time. So let's do just that. Let's make Mario. Let's run Mario. What does it have to print for? Okay, this is looking a little better, but I would say that I'm still missing something. What am I missing here?
Ouais, bah non. Ah si. 1, 2, 3, 4, 5. Ouais, effectivement.
The height with pyramid is supposed to be 4, so I should see
Mais si
1,
on
2, 3,
commence à...
4, but I'm just seeing 1,
commence à 0.
2, 3. I'm missing 1 row. Yeah, exactly. But how do I fix that? Like, how do I make it 4 rows?
Mais
where
parce
I
que
need
bon, on
it?
commence à 0, donc faut mettre... je sais pas. On commence à 0, donc je sais pas.
Any suggestions of how we can change this code? Okay, so seeing some options. I is less than height plus 1. Okay, but I'll sort of just like stop it, right? But like I'm missing something on the very first row, right? Like I'm not printing out anything on the first row. So maybe we can notice that in the beginning we initialize I to 0, right? Like this is where we initialize it for the first time.
Ça marchait,
to
mais
0.
non.
So when I do print row for the first time, I'm actually doing print row 0. So naturally it's gonna go inside of the print row function, and it's gonna be I is less than 0, but wait, int I equals 0, I is less than 0, right? Like this will not work. So on the first iteration, print row function is actually not gonna print anything. So we need to make some changes. And for that, to solve that, we can do I plus 1. Right, so instead of starting at I equals 0, we can start at I 1. And let's make Mario.
Make Mario. Ça me fait trop rire. Chaque fois qu'elle le dit. Point slash Mario. Je suis en train de tomber amoureux. Oh, point slash Mario. Waouh. 1, 2, 3, 4, 5, 6, 7, 8. Oh, nickel.
Mario. Let's run it.
Bon, attendez. Faut que j'aille me moucher. Je reviens. Ok.
Was height of pyramid 4, and
What?
voila. I have my left-sided pyramid that goes 1, 2, 3, 4, right? Exactly as we intended. Your task now is to make it go the other way, right? Flip it. Make it a right-sided pyramid. But that you will tackle in your problem set. And let me propose just one more thing. So, for example, what happens if I do dot/Mario and then I say -2?
Yeah.
The pyramid is not printing. Well, you can't really print out a pyramid of -2, right? But I also don't want the program to kick me out completely, right? Like I want to give me out
Elle veut qu'on répète le truc. Comme dans le vidéo de David.
the chance. Like maybe the next integer that I was going to put in was actually going to be a good integer, a positive integer. How can I fix that? What can I do differently? Yeah, Shab is saying a do-while loop. Exactly. And this is where I promised I'm going to show you how the do-while loop works. So we can do just that. In the very beginning, we're going to create a variable int height. And then later,
Oula.
we're going to use our do-while loop. And the way that it is set up is a little quirky, right? A little different from what we saw. So first you're going to define the do action, right? Like something that has to happen. And then the second part is the condition, your Boolean expression, like while something is true, do X. So we're going to say height is less than 1, right? So this is sort of like the contrary of what we're trying to accomplish. So as long as height is less than 1, write 0, -2, -5. Keep prompting the user for the right input, right? Like do not stop until they give you the right input. So I'm going to move this guy inside of the do-while loop. I'm going to delete int in front of height because we've already done that on line 9. And
Oula.
I'm going to make it,
Qu'est-ce
so
que j'ai fait?
make Mario. Oops, I forgot a semicolon. I'm going to run Mario. I'm going
Attends, la copie? Ah non, la... What? Si, c'est bon. Ça devrait marcher. Non, ça peut pas marcher. Alors, déjà, il y a un espace qu'il faut pas. Ensuite, il y a le point virgule. Et voilà. Là, ça devrait marcher. Ça m'énerve parce que... Make Mario. Alors, 12, 13. Waouh. Waouh. Alors, ok. Make Mario, maintenant. Ok. Ensuite, on fait point slash Mario. Ok, nickel.
to say -2, -5, 0, 4. Okay, so this is now working as intended. You see that
What? Ça a marché?
height because we've already done that on line 9. And
Mais
I'm
what? Ça a pas marché, moi. Clear. Point Mario. Non. Make Mario. Point slash Mario. -2. Ah si, ok, c'est bon.
going to make it, so make Mario. Oops, I forgot a semicolon. And so like
Mais perfect.
any questions about this part?
Ça doit être dur de live quand même, quand on n'est pas habitué.
Yes, I can go to the bottom. Seeing none, so row function. We consider again what are the components down. Then the function name print row, which again can be whatever you choose it to be. Then the next is input, right? Int bricks is what we pass into our print row function. And then lastly is some kind of like action that we're going to take, which is print row of bricks. And again, coming back to our like visualization, our boxes. So if print row is a box, right? And something is happening here. So what we pass into this box is bricks, right? So it is the variable that we grab from the user or that we like defined earlier in main. We pass it into print row, and what we get out of it is a row of bricks, right? Depending on the size of it. So more specifically, if we had if bricks equaled 3, right? 3 bricks, what we get out is these 3 hashes in the end of using print row function. All right, this was a lot, so I'm gonna pause again and ask if folks have any questions about return types, printing. See, week 1 is where we're going to wrap up. So this was CS50 week 1 section. Thank you so much for tuning in. We're gonna be here every week at the same time. Feel free to log into Zoom again in the coming weeks. It was so nice to see all of you. My name is Yulia, and hopefully I'll see you next week. Bye everyone.
Ok, bye everyone. Hop, on y va. Pas mal, pas mal, pas mal. On a appris plein de choses. Bon, au moins on sait comment ça fonctionne, un peu une fonction, à quoi ça sert, comment régler. Alors, je ne sais pas coder, je ne sais rien faire pour l'instant, mais on va y arriver. Alors, qu'est-ce que lui nous raconte? On a le problème 7-0 aujourd'hui. Hein.
Alright, so let's talk about another thing that's kind of unique to C, which is data types and variables. And when I say unique to C, I really only mean in the context of if you've been a programmer for a really long time, you've probably not worked with
Ah,
data
il est
types
programmeur
if you've
depuis
used
very
modern
long
programming
time.
languages. Modern languages like PHP and JavaScript, which
Il est programmeur depuis very long time.
I really only mean in the context of if you've been a programmer for a really long
Ah
time.
non, non, non. Il dit que if you...
Alright, so let's talk about another thing that's kind of unique to C, which is data types and variables. And when I say unique to C, I really only mean in the context of if you've been a programmer for a really long time, you've probably not worked with data types if you've used modern programming languages. Modern languages like PHP and JavaScript, which we'll also see a little later on in the course, you don't actually have to specify the data type of a variable when you use it. You just declare it and start using it. If it's an integer, it knows it's an integer. If it's a character, it knows it's a character. If it's a word, it knows it's a string, so-called. But in C, which is an older language, we need to specify the data type of every variable that we create the first time that we use that variable. So C comes with some built-in data types, and let's get familiar with some of those. And then afterwards, we'll also talk a little bit about some of the data types that we've written.
Vous savez ce que je trouve marrant? Il met un polo par-dessus un t-shirt.
For you, so you can use them in CS50.
Mais cela dit...
First is int. The int data type is used for variables that will store integer values. So one.
Je pense que quand il est arrivé, il avait un t-shirt blanc et ils lui ont dit pour le fond vert, ça passera pas, on le verra pas. Donc, voilà, mets un truc par-dessus et voilà. Du coup, à mon avis, il a dû mettre un truc par-dessus.
2, 3, negative 1, 2, 3, and so on. Integers, which is something you should keep in mind for the quiz, always take up 4 bytes of memory, which is 32 bits. There are 8 bits in a byte. So this means that the range of values that an integer can store is limited by what can fit within 32 bits worth of information. Now, as it turns out, it was long ago decided that we would split up that range of 32 bits into negative integers and positive integers, each getting half of the range. So the range of values that we can represent with an integer range from negative 2 to the 31st power to 2 to the 31st power minus 1, because we also need a spot for 0. So basically, half of the possible values that you can fit in an int are negative, and half are positive. And roughly here, this is about negative 2 billion to about positive 2 billion, give or take a couple hundred million. So that's what you can fit in an integer variable. Now, we also have something called an unsigned integer. Now, unsigned ints are not a separate type of variable. Rather, unsigned is what's called a qualifier. It modifies the data type of integer slightly. And in this case, what unsigned means, and you can also use unsigned other data types, the integer is not the only one. What it effectively does is doubles the positive range of values that an integer can take on at the expense of no longer allowing you to take on negative values. So if you have numbers that you know will get higher than 2 billion, but less than 4 billion, for example, which is 2 to the 32nd power, you might want to use an unsigned int if you know your value will never be negative. You'll occasionally have use for unsigned variables in CS50, which is why I mention it here. But again, the range of values that you can represent with an unsigned integer, as opposed to a regular integer, are 0 to 2 to the 32nd power minus 1, or approximately 0 to 4 billion. So you've effectively doubled the positive range that you can fit, but you've given up all of the negative values. Now, as an aside, unsigned is not the only qualifier that we might see for variable data types. There are also things called short and long and const. Const we'll see a little bit later in the course. Short and long we probably won't. But just know that there are other qualifiers. Unsigned isn't the only one, but it's the only one we're going to talk about right now. So, all right, so we've covered integers. What's next? Chars. So chars are used for variables that will store single characters. Char is short for character. And sometimes you might hear people pronounce it as car.
On va prendre des notes.
So characters always take up 1 byte of memory, which is just 8 bits. So this means that they can only fit values in the range of -2 to the 7th power, or -128, to 2 to the 7th power minus 1, or 127. Thanks to ASCII,
C'est quoi le nom de la vidéo? C'est variable. Data type. Data type.
long ago decided a way to map those positive numbers from 0 to 127 to various characters that all exist on our keyboard. So as we'll see later on in the course, and you'll probably come to memorize at some point, capital A, for example, the character capital A, maps to the number 65. And the reason for that is because that's it's been assigned by the ASCII standard. Lowercase a is 97. The character 0 for the actual, when you actually type the character and not
What? Attendez,
a
stop.
little bit later in the course, short and long is not the only qualifier in negative values. Occasionally have use, you might want to use an unsigned int. Will get higher than 2 billion, but less than 4 billion, for example, which is 2 to the 32nd power. You might want to use an unsigned int if you know your value will never be negative. You'll occasionally have use for unsigned variables in CS50, which is why I mention it here. But again, the range of values that you can represent with an unsigned integer, as opposed to a regular integer, are 0 to 2 to the 32nd power minus 1, or approximately 0 to 4 billion. So you've effectively doubled the positive range that you can fit, but you've given up all of the negative values. Now, as an aside, unsigned is not the only qualifier that we might see for variable data types. There are also things called short and long and const. Const we'll see a little bit later in the course. Short and long we probably won't. But just know that there are other qualifiers. Unsigned isn't the only one, but it's the only one we're going to talk about right now. So, all right, so we've covered integers. What's next? Chars. So chars are used for variables that will store single characters. Char is short for character, and sometimes you might hear people pronounce it as car. So characters always take up 1 byte of memory, which is just 8 bits. So this means that they can only fit values in the range of -2 to the 7th power, or -128, to 2 to the 7th power minus 1, or 127. Thanks to ASCII, it was long ago decided a way to map those positive numbers from 0 to 127 to various characters that all exist on our keyboard. So as we'll see later on in the course, and you'll probably come to memorize at some point, capital A, for example, the character capital A, maps to the number 65. And the reason for that is because that's it's been assigned by the ASCII standard. Lowercase a is 97. The character 0 for the actual, when you actually type the character and not representing the number 0, is 48. You'll learn a couple of these as you go, and you'll certainly come to need them a little bit later in CS50. The next major data type is floating point numbers. So floating point numbers are also known as real numbers. They are basically numbers that have a decimal point in them. Floating point values, like integers, also can hold up to or also contain within 4 bytes of memory. Now, there's no chart here, there's no number line, because describing the range of a float isn't exactly clear or intuitive. Suffice it to say, you have 32 bits to work with. And if you have a number like pi, which has an integer part, 3, and a floating point part, or a decimal part, 0.14159, and so on, you need to be able to represent all of it, the integer part and the decimal part. So what do you think that might mean? One thing is that if the decimal part gets longer and longer, and if I have a very large integer part, I might not be able to be as precise with the decimal part, and that's really the limitation of a float. Floats have a precision problem. We only have 32 bits to work with, so we can only be so precise with our decimal part. We can't necessarily have a decimal part precise to 100 or 200 digits because we only have 32 bits to work with. So that's a limitation of a float. Now, fortunately, there's another data type called double, which somewhat deals with this problem. Doubles, like floats, are also used to store real numbers or floating point values. The difference is that doubles are double precision. They can fit 64 bits of data, or 8 bytes. What does that mean? Well, it means we can be a lot more precise with a decimal point. Instead of having pi to 7 places, maybe with a float, we can maybe have it to 30 places. And if that's important, you might want to use a double instead of a float. Basically, if you're working on anything where having a really long decimal place and a lot of precision is important, you probably want to use a double over a float. Now, for most of your work in CS50, a float should suffice, but do know that doubles exist as a way to somewhat deal with the precision problem by giving you an extra 32 bits to work with for your numbers. Now, this is not a data type. This is a type, and it's called void. And I'm talking about it here because we've probably seen it a few times already in CS50, and you might be wondering what it's all about. So void is a type. It does exist, but it's not a data type. We can't create a variable of type void and assign a value to it. But functions, for example, can have a void return type. Basically, if you see a function that has a void return type, it means it doesn't return a value. The parameter list of a function can also be void, and you've also seen that quite a bit in CS50 too. This is not a data type. This is a type, and it's called void. And I'm talking about it here because we've probably...
Avant, il parlait de quoi? Double.
Bytes. What does that mean? Well, it means we can be a lot more precise with a decimal point. Instead of having pi to 7 places, maybe with a float, we can maybe have it to 30 places. And if that's important, you might want to use a double instead of a float. Basically, if you're working on anything where having a really long decimal place and a lot of precision is important, you probably want to use a double over a float. Now, for most of your work in CS50, a float should suffice, but do know that doubles exist as a way to somewhat deal with the precision problem by giving you an extra 32 bits to work with for your numbers. Now, this is not a data type. This is a type, and it's called void. And I'm talking about it here because we've probably seen it a few times already in CS50, and you might be wondering what it's all about. So void is a type. It does exist, but it's not a data type. We can't create a variable of type void and assign a value.
2 secondes, 2 secondes. Waouh, il est sale. Non. En fait, il me gêne quand je suis en dessous là. Et je pense que je vais le vendre. Donc, faut que je le garde en bon état. Ouais, faut que je le garde en bon état parce que je pense que je vais le vendre et voilà quoi, il faut que je le garde en bon état. Bon. J'ai plein de place pour...
To it. But functions, for example, can have a void return type. Basically, if you see a function that has a void return type, it means it doesn't return a value. The parameter list of a function can also be void, and you've also seen that quite a bit in CS50 too. Int main void, does that ring a bell? Basically what that means is that main doesn't take any parameters. There's no arguments that get passed into main. Now later on we'll see that there is a way to pass arguments into main, but so far what we've seen is int main void. Main just doesn't take any arguments, and so we specify that by saying void. We're just being very explicit about the fact that it doesn't take any arguments. So for now, suffice it to say that void basically should just serve as a placeholder for you as thinking about it as nothing. It's not really doing anything. There's no return value here, there's no parameters here, it's void. It's a little more complex than that, but this should suffice for the better part of the course. And now, hopefully now you have a little bit more of a concept of what void is. All right, so those are the 5 types that you'll encounter that are built into C. But in CS50, we've also have a library, cs50.h, which you can include and which will provide you with 2 additional types that you'll probably be able to use on your assignments or just working generally programming. The first of these is bool. So the Boolean data type, or bool, is used for values you'll probably be able to use on your assignments or just working generally programming. The first of these is bool. So the Boolean data type, or bool, is used for values or variables that will store a Boolean value. If you've ever heard this term before, you might know that a Boolean value is capable of only holding 2 distinct values, true and false. Now this seems pretty fundamental, right? It's kind of a surprise that this doesn't exist in C as it's built in, and in many modern languages, of course, Booleans are a standard default data type, but in C, they're actually not. But we've created it for you, so if you ever need to create a variable whose type is bool, just be sure to pound include cs50.h at the beginning of your program, and you'll be able to
Les gens sur Reddit, ils sont pessimistes, je trouve. Vraiment. Ils sont tout le temps pessimistes. C'est à chaque fois pareil, ça m'énerve. Bon, c'est pas...
At the beginning of your program when you use, so you can use the string type, and then you can create variables whose data type
Bon, la string que
is
je connais.
string. Now later on in the course, we'll also see that that's not the entire story either. We'll encounter things called structures, which allow you to group maybe an integer and a string into one unit. And we can use that for some purpose, which might come in handy later on in the course. And we'll also learn about defined types, which allow you to create your own data types. We don't need to worry about that for now, but just know that that's something on the horizon, that there's a lot more to this whole type thing that I'm telling you just now. So now that we've learned a little bit about the basic data types and the CS50 data types, let's talk about how to work with variables and create them using these data types in our programs. If you want to create a variable, all you need to do is two things. First, you need to give it a type. The second thing you need to do is give it a name. Once you've done that and slapped a semicolon at the end of that line, you've created a variable. So here's two examples. Int number semicolon, char letter semicolon. What have I done here? I've created two variables. The first, the variable's name is number, and number is capable of holding integer type values because its type is int. Letter is another variable that can hold characters because its data type is char. Pretty straightforward, right? If you find yourself in a situation where you need to create multiple variables...
Attendez, stop. Ça veut dire que... Ah, ok. Attendez. Int, height, just, regular width. Float, SURT 2, T3,pi.
of the same type, you only need to specify the type name once, then just list as many variables of that type as you need. So I could, for example, here in this third line of code, say int height semicolon, new line, int width semicolon, and that would work too. I'd still get two variables called height and width, each of which is an integer, but I'm allowed to, thanks to C syntax, consolidate it into a single line, int height, comma width, semicolon, and it's the same thing. I've created two variables, one called height, one called width, both of which are capable of holding integer type values. Similarly here, I can create three floating point values at once. I can maybe create a variable called square root of 2, which presumably will eventually hold the floating point representation of the square root of 2, square root of 3, and pi. I could have done this on three separate lines, float square root 2, semicolon, float square root 3, semicolon, float pi, semicolon, and that would work too. But again, I can just consolidate this into a single line of code, makes things a little bit shorter, not type of that variable anymore. In fact, if you do so, you might end up with some weird consequences that we'll kind of gloss over for now, but suffice it to say, weird things are going to start happening if you inadvertently redeclare variables with the same name over and over. So here I have 4 lines of code, and I have a couple of comments there just indicating what's happening on each line just to help you get situated in what's going on. So int number semicolon, we saw that previously. That's a variable declaration. I've now created a variable called number that's capable of holding integer type values. So I've declared it. The next line, I'm assigning a value to number. Number equals 17. What's happening there? I'm putting the number 17 inside of that variable. So if I ever then print out what the contents of number are later on, it'll tell me it's 17. So I've declared a variable, and then I've assigned it. We can repeat the process again with letter, char letter, semicolon, that's a declaration. Letter equals capital H, that's an assignment. Pretty straightforward too. Now, this letter equals...
Attendez, stop. Laissez-moi lire. Ok.
Equals capital H. Lines of code up above. Char letter equals H is the same as the third and fourth lines of code above. The most important takeaway here when we're declaring and assigning variables is after we've declared it, notice I'm not using the data type again. I'm not saying int number equals 17 on the second line of code, for example. I'm just saying number equals 17. Again, redeclaring a variable after you've already declared it can lead to some weird consequences, so just be careful of that. I'm Doug Lloyd, and this is CS50.
Ok. C'était vachement intéressant, on a appris plein de choses. Oh, purée. Non mais attends. John Harvard. Ouais, c'est lui qui a rendu riche Harvard, quoi. Ils sont très actifs sur Google, donc. Hmm. Eh ben. Mais ça correspond à quoi, c'est ça le truc? Ok. Bon, ça m'intéresse, mais non. Ok. Allez, on a 12 minutes de vidéo.
All right,
Et
so
on
let's
a
talk
14
about
minutes.
operators in C. So we've already seen one, in fact, equals, the assignment operator. It allows us to put a value into a variable. That's the assignment operator, single equal sign. In order to manipulate and work with values and variables in C, we have a number of operators at our disposal that we can use. Let's take a look at some of the common ones, starting with arithmetic operators. As you might expect, we can do pretty basic math operations in C. We can add, subtract, multiply, and divide numbers using. Right? How about this next line of code? X equals x times 5. Well, before we executed this line of code, x was 11. So what is the value of x after this line of code? Take a second. So x equals x times 5. X was 11, so x equals 11 times 5, or 55. So if you said 55, you'd be right. Now, it's maybe a little confusing, but with the way that assignment works in C is the value on the right gets assigned to the value on the left.
Normalement, ça
So
devrait être réglé
first
le
we
problème
evaluate
de
x times
live.
5, so 11 times 5 is 55, and then we store that value in x. The 11 that was there before is now overwritten, so x's value is now 55. Hopefully that's fairly straightforward. There's another operator that you've probably not necessarily heard called this, but you've certainly worked with in the past if you remember your days of long division way back in grade school, and it's called the modulus operator. What modulus does is it gives you the remainder when you divide two numbers together. So if I divide 13, if I say 13 divided by 4, what's the remainder? And that value would be calculated by the modulus operator. So I have another line of code here, int m
Allez,
equals 13 mod 4, and I say here in a comment that m's value is now 1. Why do I say that? Well, do the long division out in your head if you bear with me for a second. So I have 4 divided by 13. 4 goes into 13 3 times with a remainder of 1. So that's basically all the modulus operator does, is it tells you when you divide, you get the remainder. You might think that that's actually not a terribly useful thing, but you'd be surprised actually by how frequently that modulus operator can come in handy. There's a couple of problems we'll do in CS50 that deal with it, and it's also good for doing things like random numbers. So for example, if you've ever heard of a random number generator, that's going to give you a number from 0 to some huge number, but maybe you only really need a number from 0 to 20. If you use the modulus operator on that giant number that gets generated by the random number generator, you're going to take whatever huge value it is, divide it by 20, and get the remainder. The remainder can only be a value from 0 to 19. So you use modulus operator to take this huge number and whittle it down to something a little more meaningful. I'm pretty sure you'll be able to use both of those at some point in the future in CS50. So C also gives us a way to apply an arithmetic operator to a single variable in a little more shorthand way. So on the previous slide, we saw x equals x times 5. That worked. X times 5 then gets stored back in x. There's a shorter way to do it though, and this is the syntax x times equals 5. It's the same exact thing as saying x equals x times 5. It's just a slightly shorter way to do it. And when you see some distribution code or you see some sample code that does things like this, just be familiar with what this syntax means. You certainly don't have to use it, but if you do, it might make your code look a little slicker. And know that you can also use any of the different operators we've already seen before instead of times. So you could say x plus equals 5, minus equals 5, times, divide, and mod. All of those work. There's also something that's so common in C that we've decided to refine that even further. Incrementing a variable by 1 or decrementing a variable by 1 is such a common thing, especially when we talk about loops a little later on, that we've decided that instead of saying something like x plus equals 1 or x equals x plus 1, we've even shorthanded that to x plus plus. So x equals x plus 1, x plus equals 1, and x plus plus all do the same thing. They all increment x by 1. But that incrementing and decrementing by 1 is so common that we have plus plus and minus minus that allow us to shorthand that even further. So let's switch gears for a second and talk about Boolean expressions, all of which are also kind of fall into the overall category of operators, but Boolean expressions, unlike arithmetic operators, are used for comparing values.
They can't.
So again, all Boolean expressions in C evaluate to one of two possible values, recall, true or false. That's the only two values that a Boolean variable can take on. We can use the results of a Boolean expression in a lot of ways in programming. In fact, you'll be doing this quite a lot. For example, we might decide, well, if some condition is true, maybe I'll take this branch down my code, a conditional, so to speak, and we'll learn about those soon too. Or maybe, as long as this is true, I want to keep doing this over and over and over, a loop. In both cases, know that we're using a Boolean expression, a true or false, to decide whether or not to take a particular path. Sometimes when we're working with Boolean expressions, we will use variables of type bool. You might have declared a bool type variable and you'll use it in your Boolean expression, but you don't always have to. As it turns out, in C, every non-zero value is the same as saying true. If you had declared a variable of type Boolean and assigned it the value true, that's the same as declaring an integer and assigning it the value 1, 2, 3, or really any value whatsoever other than 0. Because in C, every non-zero value is true. 0, on the other hand, is false. This might come in handy later on to know, but just something to keep in mind. We don't always have to use Boolean type variables when we are working with Boolean expressions. There are two main types of Boolean expressions that we'll work with: logical operators and relational operators. The language there is not terribly important. It's really just how I'm grouping them. And you'll certainly, I think, quickly realize what a relational operator is based on what they are when we talk about them in a second. But don't worry about necessarily memorizing the term logical operator or relational operator. I'm just using it to group them in a logical way. So let's take a look at the three logical operators that we'll see quite a bit in programming in CS50 and programming more generally. Logical AND is true if and only if both operands are true, otherwise false. What does that mean? So let's say that I am at a point in my code where I have two variables, x and y, and I want to decide whether to do something in my code based on if x is true and y is true. I only want to do it if both of them are true. Otherwise, I don't want to go down that path because it's not going to help me. What I can say is if x ampersand ampersand y. That will be a logical Boolean expression comparing x and y and taking a certain path based on what their values are. So if x is true and y is true based on this truth table here, only then will we go down that path if x ampersand ampersand y. It's only true. The AND is only true if x is true and y is true. If either one of them is false, as we see in the truth table, then both x and y are not true, and so x ampersand ampersand y is false.
My second goal.
Logical OR is true if and only if at least one operand is true, otherwise false. So logical AND required both x and y to be true. Logical OR requires x to be true, or y to be true, or both x and y to be true. So again, we kind of find ourselves in a situation where we're going through our code and we've reached a fork in the road, and we want to go down a particular path if x is true or if y is true, but not necessarily if both are true, but possibly if both are true. So if x is true and y is true, we'll go down that path. X is true, one of them is true, right? If x is true and y is true. If x is true and y is false, one of them is still true, so x or y is still true. If x is false and y is true, No, one of them is still true, right? Y is true in this case, so it's true that x or y is true. Only if x is false and y is false do we not go down that path, because neither x nor y is true. Now, if you're looking at the screen right now and wondering what that symbol is for logical OR, it's called the vertical bar. And if you look at your keyboard for a minute, as I'm doing now, it's usually just above the enter key on most keyboards, on the same key as the backslash. It's also usually right next to the square brackets. So it might be a key that you haven't typed very much in the past, but if you're ever doing logical comparisons, as we'll be doing a lot in the course, it's going to be useful to find that key and use it. So it's usually on the same key as backslash, just above enter. The final logical operator is
Je viens d'avoir une idée. On finit ça? Parce que là, il reste beaucoup de temps.
not, and not let's talk about relational operators. Again, if you're familiar with this from arithmetic back in
Désolé
grade
pour
school,
le.
you're probably
Je sais pas
familiar
si
with how
là.
these work already. These behave exactly as you'd expect. So less than is true in this example if x is less than y. So if x is 4 and y is 6, x is less than y. That's true. Less than or equal to works pretty similarly. If x is 4 and y is 4, then x is less than or equal to y. Greater than, x is greater than y. And greater than or equal to, x is greater than or equal to y. If it's true, then you'll pass that expression and you'll go down the path in the road. If you have an if x is greater than y and x in fact is greater than y, you'll do whatever is subject to that condition. Notice that we don't have a single character for less than or equal to, as you might be familiar with from math textbooks. So we have the less than symbol followed by an equal sign. That's how we represent less than or equal to. And similarly, do we do that for greater than or equal to. The final two relational operators that are important are testing for equality and inequality. So if x equals y is true if x and y's value is the same. If x is 10 and y is 10, then x equals y is true. If x is 10 and y is 11, x equals y is not true. We can also test for inequality using exclamation point or bang or not again. If x is not equal to y, then if that's the test we're using here, we'll be good to go. So if x is not equal to y, we'll go down that path. Be really careful here. It's a really common mistake, and one I certainly made quite a lot when I was getting started, to accidentally mistake the assignment operator the behavior you intend. I'm Doug Lloyd, and this is CS50.
Ok. Bon, il reste une minute. Je vais prendre juste mes compléments. Je comprends pas. Pas non plus. Bon, on va faire. Oméga 2, Oméga 3, pardon. Ah là. Ah, là, j'ai pas besoin. Ok. Bon, on fait 20 minutes de pause. Après, on revient comme jamais. Une de pause. Alors, je suis désolé de pas être autant actif, aussi rapide et tout. En fait, je change radicalement les choses dans ce que je veux faire. Je change radicalement les choses dans ce que je veux faire dans ma vie actuellement. Et j'ai envie d'évoluer un petit peu dans ce que je veux faire. C'est-à-dire que là, en ce moment, je live beaucoup. Euh, C'est-à-dire que je live beaucoup. Ça signifie que de 6h à midi, je suis là et voilà. Sauf que l'après-midi, je ne bosse presque pas. Et ça me saoule. Donc j'ai envie de live un peu l'après-midi et problème, j'arrive pas à me concentrer l'après-midi. Et j'ai un gros souci et je pense que c'est parce que je suis pas en live. Il y a un gros souci parce que je pense que je suis tellement habitué à être en live, bosser en live que en dehors des lives, je n'arrive plus à bosser. Je suis totalement perdu en dehors de live. Je n'arrive plus à bosser tranquillement car en fait, littéralement ma vie sans les lives, et ben elle se réduit à voilà. Voilà. Donc forcément, ça a dû toucher un peu ma vie. Alors, pour ce qui est de ça, on va réduire un petit peu. On va mettre voilà. Voilà. Ça, on va mettre voilà. Je pense que je peux percer, mais il va falloir que je sois hyper radical sur certaines choses et je ne peux pas l'être pour l'instant. Sauf si... Voilà, il va falloir que je sois hyper radical sur certaines choses et actuellement, ce n'est pas le cas. Par exemple, là ça va, là j'aime bien, ça c'est la fenêtre que j'aime bien, ça aussi. Je vais viser la niche des 1% qui percent dans... je sais pas si vous vous rendez compte, mais je vais essayer de viser la niche des 1% qui percent dans, dans le deep focus. Vous savez ce que c'est le deep focus? Bah, en gros, c'est un mec qui travaille et vous voyez que ça, avec la musique en arrière-plan, c'est tout. C'est ça. C'est ça la musique, c'est toute la journée pareil, c'est toujours comme ça. Putain, mais la coupe est mauvaise! C'est une dinguerie! Je pense que je peux devenir grand, très grand dans le deep focus. Il faut juste que j'arrive à... voilà. Attendez, la musique elle est comment? Mais c'est une image, elle est rien, elle n'est pas animée, rien. C'était ça le... En fait, on se rend pas compte, mais voir un mec qui bosse, ça motive, mais de ouf. C'est ça, hein, vraiment, ça motive de ouf. Donc, regarde. Disons que mettre de loin un peu. Ouais, vite. Voilà. Mmh. En fait, l'idée est bonne, mais mal orchestrée. L'idée est très bonne, mais elle est mal orchestrée. Vous savez pourquoi? Parce que je suis pas un streamer. Moi. Vous savez pourquoi? Parce que moi, je suis pas un streamer. Non. Moi, ce que je suis un bosseur. Je suis pas un streamer et je suis certainement pas un mec qui est là pour s'amuser. Pas tout de suite, en tout cas. Je le serai à un moment donné, mais pas tout de suite. Et pour le moment, pour le moment, je pense sincèrement que là, on a un bon truc. Là, j'aime bien. Là, quand vous voyez ça, moi, je vous dis, vous voyez un mec qui bosse, là, ça vous motive de ouf. En plus, avec la musique et tout, moi, je pense que ça vous motive de ouf. Les gens viennent pour vous voir bosser. Ils viennent pas pour vous voir parler, en fait. C'est ça aussi le truc. Voilà, là, regardez, quand je parle. Ouais, alors j'ai coupé le son du coup de la musique, du coup, vous m'entendez respirer, c'est normal. En fait, le problème, c'est que les sons comme ça, là, ceux que je veux utiliser, ils sont sous droit d'auteur, je crois. J'ai pas le droit de les prendre Parce que sinon, je me fais strike tous mes lives. Du coup, je suis obligé de taper droit libre, mais je suis pas sûr que c'est la même qualité ou. Ah si, peut-être droit libre. Peut-être en vrai. Bon, on va taper, ça c'est tout ce on va taper. Oh non. C'est vraiment vif que j'ai mon nouveau processeur, frère, parce que avec le nouveau processeur, ça va aller tellement vite, ça va être tellement bien. Mais là, c'est lent, c'est. Je déteste. Là, c'est lent, c'est long, tout est long. Ça m'énerve. Donc vraiment. Quelle musique j'ai téléchargée maintenant, putain. Ok, c'est bon. Attendez, on va juste calculer le nombre. Combien de temps il garde l'image? Attendez. Regardez où elle tape. Oh putain. Vous savez pourquoi? C'est de l'IA. Mais en fait, il faut augmenter. Ah oui, ok. Je crois que je sais pourquoi ça casse. Mais 10 000. C'est pour ça qu'il y a un problème de... C'est parce que... y a YouTube qui prend trop la cause. C'est pour ça... faut attendre le répétiteur en fait. Ok, attendez. Mhm, mhm. Mhm. Pourquoi il est comme ça? Ah oui, ok. C'est normal, c'est ma tête en gros plan. En fait, on a coupé la moitié, donc forcément. Ah voilà. En fait, je raid vos. Pourquoi c'est dingue ça qu'ils soient pas. Hmm. Hmm, 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 hmm. Hmm, 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 hmm. Ok, bon. Attendez, je règle les problèmes d'audio là. Comme d'habitude, il faut. Voilà. L'idée est pas mal, mais. Ah. Et pourquoi ça fait ça là? Pourquoi le CTRLZ il marche pas aussi là? Casse-bonbon là. Voilà. Voilà. Mhm. Mhm. Attendez, j'ai même plus l'heure là. Elle est où l'heure? Ah, j'en ai. C'est bien sûr. Du coup, parfois il est au-dessus, parfois il est en dessous. C'est pas logique. Du coup, le mieux c'est quand même de le mettre au-dessus. Voilà. Ça, j'aime bien. Ah, c'est beau. Ok, voilà. Ok, bon, ça c'est fait. Ici, il faut mettre de l'heure. L'heure. Ah ouais, je sais, il y a des problèmes. Les problèmes de live, je sais bien, mesdames, messieurs, je sais. Je sais qu'il y a des problèmes de live, mesdames, messieurs, mais je ne peux rien y faire. Il faut que j'y attende la fin du live. Je réglerai ça pour demain. J'y arrive. Bon, alors, ça, on supprime. Ça, on supprime. Ça, on supprime. Oh. Alors, attendez. J'ai juste oublié ça. Voilà. Là, du coup, il faut inverser. Ok. 2 secondes. Tiens. Je vais voir. On en parle à midi. On en parle à midi. Et Ok. Bon, je suis désolé, ce jour-là, on ne travaille pas beaucoup. Parce que je règle tous les problèmes. Déjà, sauf de live. Le live, voilà. Bien, comme ça. Ah, c'est pas mal ça. Mhm. Mhm. Euh, Picture, 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 picture. Picture, picture. Ah oui, il y a plein de trucs. C'est vrai. Hmm. Un endroit où c'est toujours bien stratégique. Par exemple, ça, c'est pas stratégique, ça, là. Ah, déjà ici, c'est pas l'inverse, c'est l'inverse normalement. Voilà. Ça, c'est pas mis. Ok. 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 Putain, 2 fois je réponds, hein. Ah là là, la vieillesse. Mhm, mhm, mhm. Voilà. Ouais, ce serait bien que je mette genre ici. c'est très bien que je mette la caméra en arrière-plan avec l'opacité au plus bas. Ce serait bien. Ouais. Ok. Bon, c'est pas mal. On a réglé tout ce qu'il fallait comme problème. Maintenant, il faut auto-switch. J'avais essayé de l'installer, c'était buggé, bon, un peu comme souvent. Voilà, bon, je vais essayer ce après-midi. Mhm. Aussi. Donc ouais. Mm, 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 mm. Attendez, je vais demander. Attends, quelle couleur? Ok. Alors, attends, juste 2 secondes. Comment on modifie HTML, on va le modifier. Ah, mais pourquoi il veut pas là? Ça a changé mon... Ah, il est en anglais. C'est pour ça, le CTRL Z il marchait plus, putain. Pour ça du coup. Euh, C'est pour ça, ok. Du coup, ça expliquait pourquoi il marchait plus. What? Ah, si, c'est ça. Voilà. J'ai la flemme de le faire donc. Juste là où? Bon, on va tout remplacer, on va voir. Voilà, c'est pas ça. T'es sûr que ça a changé? Attends, laissez-moi ça. Juste. En fait, j'ai supprimé. Mhm. Je crois qu'il a tout cassé. Il a tout cassé, je crois. Ah, il est trop, très très beau, mais... Mhm. Oh là. Oh là 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 là, ça bug à mort là. Transparent, et aussi je sais pas écrire. Mais ça fait que bugger frère mon PC là. Ok. Voilà. Ok. Voilà. Mhm, mhm, mhm. Voilà. Voilà. Ça c'est bon. Oh. Il restait combien de temps à nouveau avant la pause? Master. Oh non, merde. Oh là là, faut que je trouve ma tirade. Bon. Je sais plus combien de temps il restait. Bon, on va prendre la pause de toute façon et puis on revient pour 10 heures. On va prendre la pause. De toute façon, ça on revient pour 10 heures et 10 heures, on se lance dans tout ce qu'il faut. Ok? Avec tous les problèmes de live là qu'il y a, ça me donne pas trop envie en plus. son, attendez. Voilà. Ouais, normalement, le son il devrait être meilleur. Je suis désolé, le son il est monté d'un coup. Ok, bon. Pause. On fait une pause.
So what is the main difference between a normal student who can only study a couple of hours
Ok. Ok, ok. Et maintenant, moi, je veux juste surtout. On va rendre ça plus beau. Attendez, je réfléchis à comment rendre ça plus beau. Allez, voilà. Mon programme. En 2 heures, PM. 14, 15, 16, 17. Bon, 4 heures, ouais. Mhm. Tous les mercredis, 14 heures, pareil. Hmm. Ouais, je vais mettre ça à chaque fois. Hmm. Je sais pas si c'est apprentissage par exemple. Learning. Il faut rester, tu vois, il n'y a pas. Donc, au final, c'est ça. Oula, il va y avoir, je peux aller pas. Ok, allez, c'est good. Oh, mais... C'est quoi ça? Elle est active, hein. Elle est active, elle est active. Ok. Ok, ok. C'est vraiment les genres de personnes qui vont au festival et tout. Bon, c'est pas vrai, j'irai aussi, mais voilà. On a hype. Il fait encore du... Ah, il fait encore du jeu comme ça.
En fait, 16 balles, les gars. Après, on est quand même à 10 kills. Hein. Balles. Je trouve que je m'en sors pas mal, les gars. Ah, je l'avais pas vu à l'étage.
Bah à l'époque il était très connu à l'époque.
Mais attends,
Et
mon
après
PJ,
il est.
il fait quoi,
Après
là
il a lâché quoi. Après c'était plus.
En fait, on peut
Plus
pas
comme
aller
avant.
à...
C'est ouais. C'est dingue ça.
Oh mon dieu, c'est la première game de la journée, gros. Merci poulet.
Bon. Ils font un peu que ça quoi. C'est vraiment que ça toute la journée quoi. Il a 48 000 personnes. Ah ok, c'est les World Cup, ok, c'est pour ça. Moi, je vais essayer de viser les top 1 de Deep Focus et ensuite...
Yo
on
iba
développe.
muchas veces, te daban un carro y dos
Et
paletas.
ensuite... Surtout sur un live qui bug, quoi. Ouais, du coup, là, je sais, ça déconnecte et du coup, ça se reconnecte pas ou je sais pas. Euh, Ok, voilà, là. Là, par exemple, est-ce que ça marche? Ok. Là, tout marche. Mais déjà, le... Là, tout marche. Mais déjà... Ok. Ok. Ok, ok, ok. Tu vois, là, il y a un problème de cours. Ok. Ouais. Bon, désolé, il y a des problèmes de co. Vraiment, c'est une dinguerie. 37 000. Qu'est-ce que la co, elle fait à 37 000? Là, la reconnexion a été bonne. Voilà, et on va rester sur cette co. On va rester sur cette connexion parce que... Ouais, bon, voilà, c'est pas ouf, quoi. Ok, ma voix est captée beaucoup moins. Ouais, ma voix est captée beaucoup moins. Bon, c'est normal. Bah là, ça... Pourquoi j'ai les frames qui perdent autant? Mais je crois YouTube, en fait, ça bug. On va désactiver YouTube. Voilà, YouTube, on va désactiver. Voilà, YouTube, il bouffe trop, en fait. Voilà, YouTube est désactivé. YouTube, c'est nain, ça bouffe trop. En fait, carrément, je vais... Ça bouffe trop. Ok, là, normalement, dites-moi, on m'entend bien ou pas?
Et c'est pas de sa faute, c'est vachement pas de sa faute. Merci beaucoup Kev, c'est gentil. Ça fait plaisir. Merci beaucoup Kev, bienvenue, j'espère que tu vas bien.
Bon, c'est normal. Bon, on va juste... Par exemple, sur ma chaîne, par exemple... Bon, on va juste... Par exemple, sur ma chaîne, par exemple... On va sur ma chaîne pour aller voir... On va sur ma chaîne pour aller voir... Voilà, là c'est bon normalement. Voilà, c'est normal si vous m'entendez en double, c'est
Voilà.
normal. Là c'est bon normalement. Voilà, c'est normal si vous m'entendez en double, c'est normal. Là c'est bon normalement. Voilà, c'est normal si vous m'entendez en double, c'est normal. On va essayer de prendre des vidéos là. On va essayer de prendre des vidéos là. Ouais, on va essayer de prendre les vidéos et les poster. Tu vois, j'ai problème de live, donc je sais pas. Contenu. Studio vidéo. Voilà, J3. On a une semaine, quoi. J3. J4. J6. Ouais, je pense qu'en fait, je vais couper littéralement le micro le matin et je vais pas parler. Et j'ai parlé aux pauses. Je vais parler aux pauses et c'est tout. Je vais pas parler. Donc voilà. Pour ça, ça fera des vrais temps de deep focus et je serai bien. Et je serai bien. Parce que les vrais temps de deep focus, c'est ce que je cherche. Attends, il y a un truc qui va pas. Genre là, par exemple. Là, voilà. Là, attendez. Si je parle, là, maman, il est en train de capter là. Ok? Ok. Là, normalement, si là je parle. Ok, il y a même un compresseur là qui est chiant. Ok, là, voilà. Non, c'est pas bon là? Toujours pas? Ah, c'est peut-être mieux là comme ça. Voilà. Voilà. Là, on m'entend mieux. Là, on m'entend vraiment bien. Si je parle, normalement, vous m'entendez bien. Vous m'entendez vraiment bien là, normalement. Ouais, je me demande juste, voilà, si... Ok, là, normalement, là, regardez. Là, je capte, ma voix est captée. Mais elle est filtrée à mort. Voilà, c'est pour ça que ça coupe d'un coup le son. On désactive ça, voilà. Là, normalement, là, on m'entendait super bien. Là, on m'entendait super bien. On- Là, c'est censé plutôt bien marcher. Bon. Bon. Là, voilà. Aussi, surtout ça. Ça. Là, c'est censé plutôt bien marcher. Là, voilà. Là, voilà. Aussi, surtout ça. Ça. Ok. Ok. Là, voilà. Ok. Là, voilà. Là, vous êtes plutôt bien censé bien m'entendre, malgré que je sois loin du micro. Là, voilà. Là, vous êtes plutôt bien censé bien m'entendre, malgré que je sois loin du micro. Malgré que je sois loin du micro, vous êtes censé m'entendre plutôt bien. Voilà. Malgré que je sois loin du micro, vous êtes censé m'entendre plutôt bien. Sinon, ouais, au pire, on désactive ça, et puis voilà, là le son est bon. Bon, ok. On va essayer de parler plutôt bien. Avec mon micro qui. Ok, voilà. Baisser le son si ça va pas. Bon, il serait peut-être temps qu'on retourne dans CS50. Focus time. Est-ce qu'on a le temps de faire 75 minutes de nouveau, 16,50, 1h15 avec... Moi je vous propose surtout que... Attendez. Attendez. Oula. Voilà. C'est plutôt mieux comme ça. Ok, bon, je vais juste chercher à manger et puis on part sur 16,50 de nouveau. On était sur ça et on était sur les opérateurs. Vous avez vu? J'ai déconnecté YouTube. Bizarrement, ça marche. Bizarrement. J'ai déconnecté YouTube. Bizarrement, maintenant. Oh là là, j'ai du chocolat là. J'ai déconnecté YouTube. Bizarrement, là, ça marche. Il n'y a plus de problème avec les lives et tout. Alors qu'avant, il y en avait plein des problèmes. Donc voilà. C'est la faute de YouTube en fait. Non, après, à mon avis, c'est le processeur. Il est surchargé. Donc quand il y aura moins de problèmes de surcharge de processeur, là, ça ira mieux. Ok. Ça explique pourquoi. Ouais, j'aurais pas dû faire ça, j'aurais dû juste cliquer sur...
All right, so now let's talk about something really useful in programming, conditional statements. So conditional expressions allow your programs to make decisions and take different forks in the road, something I alluded to a little earlier, depending on the values of variables or based on what the user inputs at the program or at the command line, or if you have a prompt or something like that. C has a couple of different ways to express conditional expressions, which we also sometimes will call a conditional branch in your programs. And some of these are going to look pretty familiar to you from scratch, so we'll even pull them up side by side just so you can make that analogy in your head. So if is a pretty simple conditional. If you recall from scratch on the right here, you could fill in that hexagon with a Boolean expression, if mouse down, or if x is less than 10, or something like that. And then if x was less than 10, or if the mouse was in fact down, all of the code inside of the puzzle piece would execute, all the things that fit inside that C shape. Similarly, do we have if on the left there, if Boolean expression, which I'm just using as a substitute for one of the Boolean expressions we previously discussed, open curly brace, close curly brace. So think of open curly brace and close curly brace as sort of analogous to the sandwich effect of the if block on the right from scratch. If the Boolean expression in the if statement is true, then all of the lines of code between the curly braces will execute in order from top to bottom. If the Boolean expression is false, we'll skip over everything in between the curly braces because we only want to go down that fork in the road if the Boolean expression is true. We can take this one step further with if else. So this scratch block is pretty similar to the one we saw just a second ago, except it takes two different paths based on what happened. So if the mouse was down, or if x was less than 10, we'll do everything that's in between that first fork, that first C. Otherwise, if the mouse is up, or x is not less than 10, we will do everything in the second set. And that's analogous to what you see here for C. If Boolean expression, do the stuff between the first set of curly braces, else,
J'ai du mal à
do
rester...
the stuff between the second set.
J'ai du mal à rester concentré aujourd'hui, je sais pas pourquoi j'arrive pas. Parce que je pense à autre chose. Et donc ça me brusque ma concentration. Alors aujourd'hui, vu qu'on a fait pas mal de temps déjà, putain, qu'est-ce qui se passe? Ça bug de nouveau. Mais il y a quelqu'un qui nous utilise notre code ou quoi? Je crois qu'elle est assez instable la connexion en ce moment sur... test. Parce qu'elle elle est instable, elle est... C'est assez bizarre, hein. Pourtant, elle est... Ah bah... Pourquoi elle est aussi basse? Normalement, si on lance un test de connexion... Bon, le live est reconnecté. Tiens, non, on relance un test de connexion. Ah non, on a bridé. On s'est fait brider. Mhm. Non, il n'y a pas. Mhm. Alors, avec 2. 0. Alors, 3, 6, 9, 12, 22, 23, 24, 25, 26, 27, 28, 29, 30, 30, 30,5, 36, 36, 35, 35,5, 35,5. Voilà. Le jour de Noël, 14, 10, 10 000, 25. Tu vois, il y a un gros souci d'instabilité. En fait, il y a de l'instabilité partout. C'est une dinguerie. Ok. Et il est 11h.
Set of curly braces. So if the Boolean expression is true, we'll do whatever's between the first set. If the Boolean expression is false, that would trigger the else, and we would do whatever is in the second set of curly braces. Again, top to bottom, all the lines in between the braces. In C, it's possible to create an if, else chain. And in fact, you can have if, else if, else if, else if, and so on and so on and so on. In Scratch, this required nesting the blocks. You had an if else, and then you had to put another one inside of the else, and so on and so on. And it got kind of nested and complicated. But C, we don't have to do that. We can actually just have it be a chain like this. Again, as you might expect, all of these branches are mutually exclusive. You can only ever go down one of the branch. If this is true, otherwise if this is true, otherwise if this is true, otherwise do this. So all four of the branches in this example are mutually exclusive. It's an if, else chain. It is possible though, and sometimes very useful, to create a chain of not mutually exclusive branches.
Je sais plus comment on se attendait. Je suis même pas sûr que il marche le custom Discord. Attendez. Je suis même pas sûr que ça marche. Parce que moi j'avais testé, ça marchait pas. Ah si. Oula. Ah, attendez. J'avais un... En fait, c'était à l'époque. C'était ça à l'époque. Tard l'époque. C'était à l'époque. J'avais ça. Waouh! Ça me rappelle des souvenirs. Attendez. Du coup... Et j'avais appelé ça le royaume. Du coup, sur le Discord, j'avais mis... Ouais. En pire, j'ai qu'à aller sur Twitch. Il donne le lien. Non, mais c'est ma live, quoi. J'ai été avant. Ouais, et du coup, je veux, moi... Discord. Je me souviens avoir créé aussi un chatbot normalement. Mais ouais. Ouais. Bon, ok. C'est parce que ça sert à rien que je fasse des bots s'il y a personne sur mes lives pour l'instant.
In this example, only the third and fourth branches are mutually exclusive. It could be that you could satisfy the first condition, and you could satisfy the second condition, and you could satisfy the third condition, in which case you would go down the first branch, then you would go down the second branch, then you would go down the third branch. Or perhaps you satisfy the first condition and the second condition, but you don't satisfy the third condition. In this case, you go down the first branch and the second branch, and then the fourth branch. The reason for this is that the else will only bind to the nearest if. So even though there's an else here, that doesn't necessarily create a mutually exclusive chain of everything. It's only that the expression there with Boolean expression 3, that's the mutually exclusive with the else. So it is possible, and sometimes quite useful, as I said, to create a chain of not mutually exclusive branches. Let's take a look at a different kind of conditional, which you have not seen before in Scratch. There's something called the switch statement. The switch statement is kind of neat because it's a conditional statement that allows you to specify distinct cases instead of relying on Boolean expressions to make decisions for you. So for example, let's say that I have this program and I'm asking the user to provide input to me. So I say int x equals getInt, and if you're not familiar yet, getInt is a function that is also included in the CS50 library. So if you #include cs50.h, you'll have access to getInt and all of its cousins, getFloat, getString, and so on. Basically one get function for every data type that we've already discussed. So int x equals getInt. Basically what's happening is I'm at the terminal, I'm asking the user to type in a number. And here I'm switching what I'm doing depending on what the user typed at the prompt. So if they typed 1, I print out 1, and then I break. If they print 2, if they typed 2, I print out 2, and then I break. It's important to break between each case because otherwise you will fall through. So if I didn't have any breaks there and the user typed 1, what would happen is it would print 1, 2, 3, sorry. That's kind of strange behavior, right? You might think so, but there are actually some cases where this could be a pretty useful thing. So here's another example of a switch statement where I omit the breaks, but I do it on purpose. So what happens here? Think for a second. You might even want to pause the video. What happens here if the user types 4? So I've asked the user for input, and they provide the value 4. What gets printed when I do that? On the previous slide, there were breaks between all of the cases, and so it would just print 4 and then stop. But in this case, it won't. What will happen is you will fall through each case. So in this case, I've organized my cases in such a way that if the user types 4, I will print 4, 3, 2, 1, blast off. And if they typed 5, I would start at 5 and do the same thing. And if they typed 1, I would just do 1, blast off. So in this case, I'm using a switch kind of cleverly so that I do intend to fall through all the cases. But generally, you're probably going to want to break between all of them unless you have a situation like this one where you're kind of leveraging the fact that you'll fall through the cases without a break. So that's the second of the major types of conditional statements, the last of which is ? So I have two snippets of C code here, one on the left and one on the right. The one on the left should probably be pretty familiar to you. I have int x, and I probably should have, ask the user for, it should probably be int x equals getInt or something like that. And then I'm making a decision. If some Boolean expression is true, assign x the value 5. Otherwise, assign x the value 6. That on the left should probably be pretty familiar from our discussion of if-else just a moment ago. Would you be surprised to know that the line on the right does the exact same thing? So this is called ? or sometimes called the ternary operator. And it's pretty cool. It's usually used as a cute trick, but what it allows you to do is to simulate an if-else with really small, really trivially short conditional branches. You generally wouldn't use ? if you had 6 lines of code between each set of curly braces. But if you're just making a quick decision, if you're going to do one thing or the other, and it's very simple, this might be an example of how to do it with ? the ternary operator. So int x equals expression, ? The thing after the question mark is what x's value will be if expression is true. The thing after the colon is what x's value would be if the expression was false. So I'm asking myself, is the expression true? If it is, assign x the value 5. If it's not, assign x the value 6. Again, like I said, this is usually just a cute trick, and sometimes if you become really comfortable with it, you'll do this because it looks kind of cool in your programs. Generally, I'm presenting it to you now so that you're familiar with it if you see it. But certainly no, you don't have to write it in any of your code, but it is something to be familiar with because you'll definitely encounter snippets of code here and there where this question mark colon syntax, aka the ternary operator, is used. So a quick summary on what conditionals are and what the options are available to you in C. You have if and if else and if else if, etc. You can use Boolean expressions for those to make decisions. With switch statements, you use discrete cases to make decisions. You explicitly say, if it's 1 or if it's 2 or if it's 3, I'll do this thing or this thing or this thing. And question mark colon can be used to replace very simple if-else branches or if-else chains to make your code look a little fancy. I'm Doug Lloyd, and this is CS50. All right, so let's talk about loops. So loops are kind of cool because they allow your program to execute lines of code over and over and over repeatedly without having to copy and paste or otherwise repeat them. There are 3 major kinds of loops in C, and you'll probably have occasion to use each one as you progress through CS50. Some of these loops are pretty familiar to you from scratch, so again, as we did with conditionals, we'll put them up side by side if there is an analogy that we can draw. First is forever from scratch, which compares to while true. This is what we call an infinite loop. The lines of code between the curly braces, much like the puzzle pieces that fit inside the C of the forever block, will execute repeatedly from top to bottom over and over and over forever. After all, if you recall from our discussion of Boolean expressions, true is always true. So if we're doing something so long as true is true, it seems a little silly, true is always true, so it'll always run. It'll run forever and ever and ever until we find a way to break out of it with a break statement, which again we saw a little while ago when we were talking about switch, or otherwise just kill our program, which incidentally, if you ever find yourself in a situation with an infinite loop and you don't know how to stop your program from running, just hit Control and C, and that'll kill your program for you. But this again is called an infinite loop. It is a loop that will run forever. Now, while loops are not always forever. Now, while loops are not always infinite, we can also replace the Boolean expression with something a little more useful than just true. So here's another example. While, and then some Boolean expression, and then curly braces. That's pretty much analogous to repeat until from scratch, although in a second I'll explain the difference. So in C, if the Boolean expression inside of the while loop evaluates to true, the lines of code between the curly braces will execute repeatedly over and over and over until Boolean expression evaluates to false. So for example, you might have some sort of counter. So say you at the beginning of this loop, you say int x equals 0. While x is less than 100, do a couple things inside that curly braces. Then at the end of your loop, you say x plus plus. You're incrementing x, so eventually x will get to 100 and you will stop because the condition x is less than 100 will no longer be true as soon as x is equal to 100, because 100 is not less than 100. Now, somewhat confusingly, the behavior of the scratch block is reversed, so be really careful if this is your first foray into using loops. Basically, the the repeat until block in scratch will repeat something over and over and over until the expression, the Boolean expression in the hexagon, is true. So it will keep doing it until it is true. Meanwhile, the while loop will continue to do it until it is false. So they're quite similar, but there's that little distinction just to be careful of, especially as you make your first foray from transitioning to scratch into C. The next kind of loop is actually pretty similar. It's called a do-while loop. This loop will execute all of the lines of code between the curly braces once, and then it will check the Boolean expression. If the Boolean expression evaluates to true, it'll go back, and it'll repeat that process over and over and over until the Boolean expression evaluates to false. So this loop, unlike a while loop, is guaranteed to run at least one time. This would be pretty useful. Lastly, we have a for loop. For loops are kind of syntactically unattractive, and there's a lot going on here, so bear with me as we try and break these pieces apart. Generally, the use case of a for loop is you want to repeat something a specific number of times. In this example here, I have the repeat block from scratch, which is analogous to the for loop in C. Repeating something 10 times. And the for loop on the left there, which is a for loop that would do the same thing. This would go 10 times. We're counting from 0, we increment I each pass through the loop, and we keep doing that until I is less than 10. So what happens? There's a whole lot of code there. Let's break it down into what is happening step by step as we dig through a for loop. The first thing that happened is the counter variable is set, or everything to the left of that first semicolon inside the parentheses is executed. In this case, we are saying int I equals 0. We're declaring a new variable called I. That variable is of type integer, and we're saying the value inside that variable is going to be 0. The second thing we do is we then immediately evaluate the Boolean expression. The Boolean expression is in the middle of the two semicolons. I is less than 10. That's true here, right? We just set I is equal to 0, and so 0 is less than 10, and so that condition is true, and we will now proceed to execute the body of the loop. If it was false, if for example I had said instead of I equals 0 there, I had said I equals 15, int I equals 15. Well, 15 is not less than 10, so we would never enter the body of the loop because the Boolean expression there would evaluate to be false. After we go through from top to bottom and we encounter that closing curly brace, a third thing happens. The counter variable is incremented, or rather, the lines of code or the statements after the second semicolon inside of the for loop's parentheses is executed. So we start out by saying int I equals 0. Then we check whether or not the Boolean expression is true. 0 is less than 10, so it's true. So we're going to proceed into the body of the loop. Things will happen inside the loop, and when we encounter that closing curly brace, the next thing we do is we say I plus plus. So I was 0, now I is 1. Then we again check the value of the Boolean expression in the middle. 1 is less than 10. So we'll go through this process again and again. We'll finish we'll get to the closing curly brace again. We'll increment I from 1 to 2, then from 2 to 3, and so on and so on and so on until eventually I's value becomes 10. Is 10 less than 10? No. Counting from 0, we've gone through 10 iterations of the loop. We've repeated 10 times, just as we did in the scratch block. And so that's basically the process for a for loop. Now, taking away the actual code and putting it in some sample, just some basic general statements, here's what happens. All of the statements in start are executed first. You might have more than one. Then the Boolean expression is checked. If the expression evaluates to true, execute the body of the loop one time. If the expression evaluates to false, we're done. We don't execute the body of the loop at all. After we've executed the body of the loop one time, we then do what is in the increment part there, which is usually going to be something like I++ or something like that modifies a counter variable. Then, after we increment, we check the expression again, and we repeat those steps over and over and over until the expression is no longer true. So what are the use cases for a loop? You use a while loop when you want a loop to repeat an unknown number of times, but it possibly might not run at all. A really common example of a while loop being used is to run the control flow for a game. You might not know how long the user is going to be playing, but you want to keep doing the same thing, updating the positions of various sprites on the board. You want to keep things moving at all times, but you don't know when the user is going to stop playing or when they're going to run out of lives. So a while loop is really good for something like that. That's a good use case. For a do while loop, it's pretty similar. You want a loop to repeat an unknown number of times, but at least once. You might use this for a game too, but a really common use case is prompting the user for input. Generally, you might say something like, give me a positive integer. And you might put that inside of a do while loop. So it'll always ask them at least once for a positive integer. If they give you a positive integer, you might break out of the loop. You might be done. The Boolean expression in the do while might be false, and you won't ask them again. If they give you a negative number though, or they type some word or something that's not really useful to you, you might use the do while loop to go back and do it again and again and again. You definitely want to ask them to give you a number once, but you don't know how many times after that they might be pests. And so a do while loop is a great use case for prompting the user for input. And a for loops use case typically is when you want to repeat a loop a discrete number of times, though you might not know the number of times at the moment the program is compiled. So for example, maybe you have a program where you prompt the user for a number, say, and they enter 100. And maybe your for loop will then in that case run 100 times. Or maybe they enter 1,000, and your program would then run the loop 1,000 times. It's a specific number of times, but you don't necessarily know what that number is the moment the program is compiled. It's not like a while loop where it could be infinite. It's rather a number that you just don't know. Now, even though I've outlined all these use cases, you should know that in pretty much every circumstance, you can interchange all three of these loops. You can use a for loop where you would otherwise use a while loop. You can use a for loop wherever you would use a do while loop, and so on. It can be a little tricky sometimes, so generally it's a good practice to adhere to a typical use case. Use a do while loop if you want to do something once at least. Use a for loop if you want to do something a specific number of times. After all, that's why there are 3 different kinds of loops, so that they can be used in the right context. But you can interchange them if you want. If you feel comfortable with while loops and you always want to use while loops, it is something that you can do, although it might be a little syntactically tricky, where a for loop would be a lot more straightforward. My name is Doug Lloyd, and this is CS50.
Sab, you know the setup by now. Exam season. Let's go. See you guys in 50 minutes. Hi guys, it's Sab. Welcome back to the channel. You know,
C'est vrai, c'est apaisant. Et je rigole pas, c'est vraiment apaisant. J'aime beaucoup l'ambiance, alors que elle a rien, mais rien d'exceptionnel. C'est ouf, mais j'adore l'ambiance.
we're done radiology.
Mais c'est ouf le monde de... En fait, il faudrait que j'investisse dans une meilleure caméra grand angle, en fait, parce que la qualité là, elle est horrible. Donc forcément... et on n'en parle même pas de la qualité en 1080p. Elle est encore pire. C'est de la 2K, mais 2K, 2K grand... 2K de mauvaise qualité, quoi. C'est ça le truc aussi. Touche pas. Oui, oui. Qu'est-ce qu'il y a? Ah, attends, regardez. Regardez. Eh, tu l'embêtes. Ah, Nova. T'es chiante. T'es chiante, t'embêtes tout le monde. Dégage. Oh là là. Ils se battent tout le temps les deux là. Euh, Ils jouent et puis après en fait l'autre là il attaque là. C'est pour ça aussi ça. Il faut les séparer à chaque fois. C'est chiant. Alors. Ok. Je cherche quelque chose. Je vais rendre juste. Je capte la lumière du jour. Voilà, il capte pas la lumière du jour. C'est que si j'achète une webcam, il capterait pas la lumière du jour. Mhm. Ah, mhm. Non. Tu veux sortir? Tu ouvrir une porte, non? On va réussir. Bon. Elle a réussi. Elle a réussi à ouvrir la porte. Bon. Ça me gratte au niveau de la jambe là. Non, je me gratte pas les couilles, si jamais. Ok, bon, finalement, c'est pas... C'est pas fameux, quoi. Oh, purée. Mm, mm, mm. Ouais. Mhm. Ok. Ok. Ah, mais non plus, elle pense 60 FPS. Ouais. Après, tu vois le truc. On s'en fout que ça soit en 60 FPS, regarde. Elle aussi, elle est en 30 FPS pourtant. Ça va. Regarde, elle est en 30 FPS aussi. Et pourtant, c'est fluide. Donc, ça, en vrai, ça va. C'est plus fluide que chez la caméra là. Donc, en vrai, je pense que je vais la prendre. Ouais. Non. Moi, je mange pizza, moi. Pizza. Bah, tu fais ce que tu veux, ouais. Tu peux faire ça. Moi, je veux pizza. Ouais. Ouais. Au pire, on s'en fout, ouais. Bon. C'est bon de savoir si on prend ou pas. Bon. Et, elle a un angle de 90 degrés l'autre, celle-là.
Ouais.
Bon. Allez hop. Merci beaucoup d'avoir été présent. On n'a pas fait grand chose ce matin, désolé. Mais on bossera demain beaucoup plus. Peut-être cet après-midi je live, on verra. On verra, pas sûr. Ciao ciao. Peace.